So if you have a 3-core or 2-core, if the cables are together, they are together. If there is,
yes, sir,
because of easy maintenance,
yes, sir,
1 core. All right.
single core. Yes, sir.
All right.
Okay, so
Oguke, your hand is up. You're welcome.
Thank you so much.
Yeah, you're welcome. Oguke, your hand is up.
Oh,
Victor.
yeah, good afternoon, sir.
Good afternoon.
Yeah, I want to ask a question, and from your explanation, if the cable inside my
Thank you.
okay, it means if one of the inverter is overloaded,
Of course,
it will
be hot because that's the transmission. That's the transmission. Obviously, the cable will be hot. That's the reason why for you to do your design, you do your audit, and do your audit. You are going to see if you are doing if you need to do load balance. Line 1 will not be, the load on line 1 will not be high. The ones
is even tripping on high temperature. So I need to go and rebalance that. Okay.
All right. Ibrahim, go next. Ibrahim,
okay.
Go next.
Good afternoon. Okay, still morning. Good morning. Thank you very much. Last question, this is C&I. Now, supposing you have a system that you have size, maybe oversized, with an expectation of load. Now, how do you attempt to manage zero export to the grid? Since it may likely be a grid system, grid system, let me put it this way, the grid system.
Okay. So if you want to manage, like you oversize your system and you have more load that you can feed your clients, right?
More load. More load.
So let me tell you now about size. Because what we are saying here, when you oversize, you're increasing your capex. All right, and when you increase your capex, your clients might not be able to pay. So this you don't increase the power in the low. All right, because there's what we call curtailment. Just know that the excess power will be more. He told you that they are expanding. All right, so your sizing has covered their present load and their future load. So pending when they meet their future load, they are still paying you for it. So to avoid excess load, we have a controller. All right, which we are going to talk about in PV Diesel. We have a controller. NOM controller has an export limitation. All right, so once you have an export limitation, the controller will stop you anything to grid. Since if it is Nigeria, we don't export to grid. We are not selling to grid, so the system will stop.
Okay, all right.
You're welcome. All right, I want to start PV Diesel. Adebutu, your hand is still Adetu. Okay. Ade John. Ade, you can go next.
Thank you very much.
You're welcome.
I'm grateful.
You're welcome.
The major factor.
Definitely.
Now, in the soil, how do we determine the temperature? If you want to bury your cable under the soil, and temperature is a factor, how do you determine the temperature?
To determine the temperature.
That is one.
Okay.
I was going through it. I detect two things, sir.
Okay.
One, where I can get the Google map to indicate the roof and the surrounding building. I did not get that one clearly. I want the site. That's one. Then in dimension.
Thank you. All right, thank you. So the first one, to know the soil resistivity of your to know the temperature of
I
the
think soil term.
yeah, to know the the temperature of the soil, right? So most of the time, you need to know your soil resistivity. And how do you know your soil resistivity? Is to employ experts to do that. We will give you the value. All right. So you have to do that. But if it is preliminary, right? Like preliminary means that the client has not committed. You just then you can ask, right? You can assume value just to get the everything running. Then doing detailed design, you'll be able to know the temperature and the rest. All right. Then the other question that you asked regarding what is it? Can you just hint me regarding
The map.
So regarding map, don't worry. Next week we're going to be treating a case you the necessary map, the Google Earth Pro, the map, Google Map, so that we're going to see how to know the area of the. And the last one regarding the unit of the of your panel. Panel is the you can it depends on what you want to do.
But in that
You can work with
like in that example, is it meter? Thank you.
All right, Ayotunde, you are the last person. Ask your question now so that we can start with PV Diesel.
The AC cable run between the PV inverter is preferable to use a single core. Most times, I think in CNI, for that inverter to combiner box, we use 4-core by 95 mm, positive and negative for all the number of inverters instead of using 4 by 95 mm. Just one
All right, so now what I'm saying is 95 mm. You understand? Let's not try because you've done an installation on one and you are doing another installation. The inverter is also 100 and the installation modes are different. Where the cable, so there is no fixed cable size. You just have to do your calculation. Now you cannot use multiple. So, the project manager, the cost. He has the cost of all the cables. If it is the cost, if this installation, let's go with all right. Let's go with understand it. I can for a client now. Okay, to use. If I have the same, going to be let's not cram design. Just go with the flow.
What the from the system. Yeah, the house breaker.
This is it. It's only or to maximize its fuel consumption. I'm going to explain to you now. But before we go, let me just show you something. Every generator man of it. All right, I'm back. Can you hear me now? Can you hear me?
Yes, you can.
All right, start this again.
Yes, can see your screen.
Can you see?
So, PF, SW power.
See the different capacities of generator.
Yeah, just go.
It will open. I'll get back to you. All right, so let's just do. So now, the PV. So what I'm trying to say here is that you're running your generator for different capacity, right? So you're do at a minimum. Once your generator at a minimum, there is minimum, right? So distant generators or remote areas unserved by the grid have most operation and have most of the not. So you know how of the sun is not. That only operate during the day. Obviously, PV diesel hybrid system is the best for them to use. There will be a lot of. Now, those who rely on diesel primary sources suffer from high costs that are hard to predict due to fluctuation in the price of oil, the cost of transport, and taxes. All those big companies, I'm sure you know that they are not connected to grid. They constantly resource. By the time you spend all your profits maintaining generator, running generator or gas generator, then it's as good as you closing your shop. So that's where you have your people to still assure that they will have what's it called? They have optimized system. All right, that's of Nigerian public company. The likes of Nigeria 7-Up, they all have PV diesel system. If you buy with pollution, I'm sure pollution from your PV need aluminum. The next that power from, you can see the PV inverter, we can call it on-grid inverter, solar inverter, PV inverter, you know, just understand the meaning. Then the next one is what is your fuel saver controller, which is the intelligence management controller. You can see this is it here. Then the sixth part is what genset can have multiple generators. All right, like I think 7-Up, they have 5 generators. Go to all these manufacturing companies, don't have more, it is multiple generators. Though they have multiple generators, your PV can still be integrated seamlessly with the help of the controller. Now, what is the safety realize or pay grid failure, grid for fraud like it, and there is a grid failure, your power automatically switches to your generator, right? If your generator, that you are in the power generator, PV uses the costs at the minimum load, and your solar and other sustainable investments, reduce that we talked about, cash in on incentive and enjoy tax benefits. That is the incentive. I don't know if those in Kenya or other country are enjoying it. This is just the, look at this. Look at this first. It's
Yes.
switch. Yeah, that's the there is available. It is, can you see the not is coming down? So the grid is the one supplying the power. That's on the now generate utility is on means the generator now in this you can see on the degree what is coming from the now looking at that this does not mean the inverter universe that is dealing the power is dealing because of the inverter out of all is required. The inverter is given 70, while below the grid is given 30. Can you see? Now, let me tell you this. The inverter does not automatically start producing. From this image, it does not automatically. The synchronize. What I mean by synchronization, which I've explained, is that the voltage must match that of the grid. There will be blackouts because the inverter is not synchronized with this. There is no reference from these two. There is no grid availability. The generator will not come up automatically, so there will be a blackout within this factory. All right. Now the generator is up now. Can you see? The generator is up. It will. There is still backup because it has not yet synced. Generator comes up. I supplied the 100, supply the whole 100 Once the generator has come up, they do not change from the generator if it can sync. If they have the same voltage, the same frequency, the same phase, then once that it can now start discharging its own power. You can see 70, then the generator to you can see that they are sharing it. The energy PV, not the remaining generator. So now let's move to the working principle. There is what we call DG hunting. What is DG hunting? There is what we call DG hunting. We are going to see that now. Of DG hunting. I'm sure you understand the capacity of our PV 50. You can see that there is grid availability, so the grid will supply everything. We supply effortlessly. Now the inverter now identify the references from the grid. Identify the reference parameter from the grid. Roll 100. It automatically starts supplying the whole 100, 100 and one generator. Can you see it? Minus 50. So one generator receives minus 50. What happened? Generator will shut down. And once generator shut down, there will be a blackout. Why? Because your inverter cannot run. Can you see? Automatically there will be a blackout. Both of them are not working. There is a blackout here. So what happened? The generator comes up again. The field service guys go and run generator again. The inverter is what parameter 100. It haunts this generator. So it keeps haunting the generator, So that's the reason why most time you notice that generator keeps going off and on, going on and on. So that is all of that. So that the first thing is to prevent DG haunting, to prevent this DG from generator from shutting down. But DG, the controller, the function of the controller in a generator is to minimize to ensure that we have minimum loading for the generator. Reverse power, that DG routine is reverse power. Remember, is always moving. It's quite good. But when you have power, this is the counter power. It makes move in anti-clockwise direction. And once the direction is right, that's why more power the power factor to the power way. All right, it's 0.2 is like 0.2. It will increase once the current the power. I'm sorry, the cable. The reserve to the PV output. The PV output reducing all of a sudden. What happened? All right, they reserve the length from the generator to back that up. We are going to see that. All right, but the function of the controller in the grid is to just like I have and right, how do you manage power from sending to the grid? You can see that's what we call feed-in control. The controller will help you that. Now it controls that. This is the main function. It controls the PV generation to maintain the maximum PV output. All right. It ensures that we have more output from the is going to have. You can have 5 generators. You can have multiple generators. The controller knows which generator is running, what its maximum loading set point is. So, can you still see my screen? What happened? Hello? All right. So it increases or decreases that generator of other power sources. Now, when you understand this, you'll be able to understand that PV can actually synchronize with other generating, be it biomass, be it generator, gas generator, be it grid. With the help of the synchronization controller, it will, as a floating PV system of heavy load does not affect the system stability. I could remember when I was pitching this to someone, and he made mention to me that in their factory that they have heavy load. I said it will work. He said they have heavy load within their system. I said yes, it will work. All right. If you go to almost all the plants that almost all the manufacturers that we have around, they are using PV diesel. It's working. All right. So you can integrate seamlessly. It will not impair that generator. It will not have to. Now, at load levels less than 30% of its rated output for an extended time period. Now, I just use 30% here. Some generators can be 20%. Some generators can be 25%. Pump sets. All right. It simply means that, for example, if someone to tell, if I have a generator of, let me assume I have 1000 kVA generator. Remember that maintaining the maximum output of solar system while protecting the DG from light loading. Light loading means you are running the generator below the minimum set. That's the meaning of light loading. All right. So this simply means that even if you have even doing peak sun hour, all right, and you let me assume that for this installation, this same 1 kVA that I mentioned, it is I mentioned that the base load is what 240 kilowatts. All right. Now, if I install, let me assume I installed 1,500 kilowatt peak solar capacity. At peak sun hour, if the 700, I mean the client load is 700. I'm sure you know that during peak sun hour, an installation of 1,500 kilowatt peak should be able to carry all the loads. That's carry all the whole 700. All right. But the controller will ensure that the PV is not carrying all the loads. All right. The PV is out of 270, so out of 700. The PV will and leave for the generator. It will leave that 240 for the generator. Do you understand? The output of the PV system that the load of the client is below 240. What will happen? The controller will switch. We switch off the output of the PV completely. We will switch it off and ensure that the generator is just carrying on the load. All right. So that is what the minimum genset loading is all about. Now, these are the symptoms of if you run the generator below its minimums for an extended period of time, what will happen? The cylinders will contain soot deposits. The turbocharger with wet stacks of soot. Carbon will build up in the piston, injector nozzle, and lining. The crankcase pressure. We are going to have high crankcase pressure, and the exhaust or manifold we have leaking. So have a generator that is performing this particular. You have a PV diesel system, and you are experiencing this in your generator. Note that is because the generator has been running below its minimum loading for a long period of time. All right. Now let's see reverse power protection. The diesel generator has a limited reverse power window. All right. Now most generators have their own protection on reverse. So I think I've explained that to you. Some generators have a window. It can be that it can only withstand maybe reverse power for 5 times after shut down. Some have that protection. Once they see, they shut down automatically. Now, to protect these from remote should be. What is mean of curtailment? You are going to see it as we proceed. Now, in case of a sudden load reduction, the controller immediately reduces the flow. The controller is very, very smart, so he knows what to do as far as you've done the settings. So this is for reverse power. To modify the reactive power, this generator is running in order to maintain a steady operating window. It helps to eliminate grid. All right, so I'm sure you know that in some country, there is a certain power factor that you should maintain. All right, if you go below that power factor, you pay some fine. All right, and I'm sure you know factor reduces. You pay more. When the power factor reduces, the current increases, and once the current increases, you pay more money. All right, so the controller helps to minimize that. Now, reverse spinning reserve. Spinning reserve is to be maintained to manage large step change in PV production output. Now, what this simply means is that, for example, if I'm sure you must have seen a situation whereby you have sun, maybe during the day around 12, you have sun in the atmosphere. You just see the cloud will just cover the cloud just cover the atmosphere. Now at that point, what will happen? Definitely you will see a drastic reduction in the PV output. All right, but with the function of spinning reserve in a controller, it helps to balance it. Including will drop. Thus can be of install capacity, you can see, and the ramp down will be this cycle, preventing DG frequent cycles and have enough reserve capacity to compensate T. So the controller have reserved, ensure that there is a reserve. Now remember, doing your controller to your generator, so the controller automatically have control of the generator. All right, automatically everything that has to do with operating it. All right, so now let's move on. So this is grid export. If PV power is not allowed to inject into the grid or other limit, like in Nigeria here, the hybrid controller can control the PV to a predefined limits. That's what we are talking about. Now, what is solar inverter zero or zero feeding device? Does the PV generator controller have this capacity? There's what we call zero exports. The power, so there are no excess power, which prevent the reverse flow of power from solar power plants to the grid. So that is just the grid curtailment. So you can see this. You can see this is the solar power. This is my inverter. This is the controller. This is the main guy here. It's very a huge function. These advantages, I'm sure we all know, these are the advantages. You can read this up on your own. Now let's see the four saver calculation. You need to know this calculation. You know how to pitch. All right. Calculation of 4 PV diesel. Now, step 1. Observe time. Now assume 30 view. What's going to get 240? That's the now observe having the 240, which is the capacity of the generator. That the load that is being consumed from the generator is 180, which is 75% against generator rating. Then you need the PV fuel saving. Now the generator run for 4 hours. all right, and log for consumption power. Now let's see. Let me just go to what is that? How is this guy not open? I want to show you the charts. Okay, it's coming up now. Diesel consumption charts. Consumption charts. Sorry, are you with me? Are you still with me? Because it seems I'm just talking to myself.
No, we are with you. We are with you.
Alright. Now, if and all the devices is going to so it's running for 4 hours. Now this one is 300 kV. Now let's assume the liters per hour was for 4 hours. Per hours is consuming 60 liters. That means for 4 hours it will consume how many? 240 liters. All right.
Yeah.
It will consume when you decrease. Now, in this case, now in step 2, I've not introduced my PV. All right. Now, decreasing the load, I'm not introducing my PV. Decreasing the load on generator by the minimum genset load is set point recommended by the generator manufacturer. All right. Like I mentioned to you, some generator recommend 25, 20, but let's assume that in this case it is 30%. 30% of this generator capacity. What is it? Remember, this is the capacity of generator. 30% of this will give us 72. So this is the base load. That means I must not run below. I'm still running the same generator for 4 hours. All right. And for the 4 hours, because I'm running the generator for 30, for running at 75.60, but if I'm running, consumption is 31 liters. So for 31 liters per hour, you can see what the capacity, the consumption is. So instead of running this instead of using 240 liters and liters, Davis, can you see the service? All right, so now you can see it has opened. Can you see it now? Can you see it? You can see it. Let's go to this. Okay, this is it. Now, if I have a see the consumption, if you run it at again, so now hard as rest is reasonably strong, you can save. You can see 29 liters per hour. Total savings, you can see 160 liters saved. Can you see? So now let's see when and where is a PV hybrid system, when does it make sense? Now under the, for example, residential unit, diesel is more than 1 or 0.5 here. When a lot of local sun irradiation, that's the reason why, all right, is the now let me come to this. For example, now this generator is 240 kilowatts, right? 240 kilowatts. Am I right? I need you to talk so that I will know that you're following. Now, if the machine a minimum genset loading, if the is recommending 25%, what would be the base load of this generator? I need someone to tell me. What would be the base load of that generator? What is the base load of the generator? If the OEM of the generator is recommending 25%, what would be the base load? 60 kilowatts, right? So that's the base load. Now let's come to this now. Now let's assume that you've done your audit. All right, you've done your audit, and you realize that the client's average load, is, let's say 70, or let's 50. This is a waste of money. So now when you look at this now, as in the case of 100 kVA DG, if your load is less than or equals to 24, 30% of it is what? 30% of it is 24. So if it is less than or equal to 24, you should 30% of the load, you don't need it. You don't need PV control for these scenarios. Now, impact of DG controller on downloading or wet stacking. I think this one you can read this on your own. It's still the same thing as the impact when you light loading, when you just like what we've just explained all around. Downloading is the practice of running generator with a lighter load than it is designed for. This way, under to reach it and let me not put more load. No, you are not helping the generator. You need to. Now, in order to achieve the best possible blend of generator performance or electromechanical reliability, manufacturer service intervals and predicted component life are determined on a normal operating range. Now, these are the impacts. The impact of genset on downloading or wet stacking, another name for downloading is wet stacking at low cylinder pressure, low temperature, internal glazing of the cylinder bus, low oil performance. You can see just like we've just explained here. So those are the impacts. Just like we've explained here. So those are the impacts. So now for personal or residential, we don't need it. You can read this on your own. We don't need it. Residential don't need it. Residential don't need it. Now let's what generator size. What generator size is recommended? Now the size of a generator or number of generators must first and foremost on demand, no amount of grid facility. Now what this is trying to say is that you must size the generator based on the load demand. All right. For example, now if the load you've done, let's assume a new facility wants to come on board, and now if that facility you size that generator based on PV or based on the solar capacity. No, they will size their generator based on their load. All right. So let's assume that they've done their own. The generator should be able to withstand the peak load. Sizing. Now, generator will always provide a steady supply in accordance with its weather. Based on your inverter capacity. What now happen if the weather is not friendly? So that means that there will be an overload. All right, your generator, your system will be short. Now the only issue with a grid-tied solar integration with genset average load. So generator rating should preferably be greater than 30% of the generating rating. All right, so that means that the average load that you want to size must be greater than the recommended percentage. Now, let's example. If the generator is the active that's 320, where the average load running on the facility is 128 kilowatt, that's 40% of the capacity. Now, assume that the generator manufacturer recorded minimum genset loading of 30%, that's 96. All right. The solar sharing will be minimal. You can see now in this case, it is also minimal. Do you understand it? Do you understand this? Now, the generator capacity is what? 400. That's 320. Right? And the average load is 128. That is 40% of the generator capacity. Now, the 30% that is recommended by the OEM is 96. Now, when you do it, 96 minus 128, that will give us what? What is it? 96 minus 128 is what?
96 minus 128.
Is what? 128 minus 96 is what?
32.
32. You can see that it's small. 32 now. If you are not in this case now, the solar sharing will be minimal, you can see, and will not make a significant impact on generators' fuel consumption. You can see. So even if it is more than 4%, it is too small. It will not make a significant effect. So in this case now, you are not really saving much. So if you have something like this, it's better not to pursue that project. Now look at the last example. Now, whereas if the same generator, if average load is 240, the generator will be running 96, that's the 30%. The rest, which is 144 kilowatt, will be taken up by the solar. You can see 144 is significant. This may lead to saving up to 30 to 40% generator. You can see. So the PV diesel is not just there to make name, is there to make savings. And if the savings is not significant, then there is no point in venturing into it. Now let's now see how to calculate our solar capacity. All right. Now maximum generator rating in kilowatt. Assuming the maximum generator is 100%. You can see maximum the generator capacity is 400. Now the minimum genset loading at 30% of the is what? 120. So this is the base load. The base load. So now if I have the base load, how do I size my solar capacity? I just need to subtract. That is the 400, which is the maximum load of the capacity. All right. Minus the load, get 280. So when you divide this 280 by 80%, the 80% is just the tolerant value. Because if you are installing 280 kilowatt peak, you cannot get the 280 kilowatt peak because of some losses. So this 80% is to cater for that losses. So if I should divide 280 divided by 80, then that would be my solar installation. All right, that would be my solar capacity. Do you know this? Let's do example. We'll round off. I think after that, that is the last page. Let's see example. Let's see example. All right. Now let me assume that generator. Let me use this average. Now the average load after I've done my audits. Like this is my average load, 690 kilowatt during the day. This is what I'm getting. All right. Now I want to know my solar capacity. What would be my solar capacity for this installation? What solar capacity should I be proposing for this type of capacity, for this type of installation? Now for 800 watts, let's as OEM recommend 25%. Let's do this together. I recommend 20%. So what will I do? I need to get my base load, right? I need to know what my base load is for this generator. So what will be my base load? What will be my base load? My base load, is 200. That's 800 multiplied by 25%, and 25% is giving me that is 25% is giving me 800, right? So it's 200.
Yes.
All right, good. Now, what will be will that give me what? This average load, 690 minus 200. For this divided 0.8, what? 490 is 0.8. You can just run the graph now. See the chart. When we've not introduced our solar system, the generator is running, the load is 690. And in a month, we are assuming that, but let's just stick to that 75% to not complicate things. Now this is 170. Can you see? So when you multiply 170 times the 200, 170 times the 200, you are going to get the generator is consuming in a month. The generator is 690. The liters is what is 3,400 liters. Do you get that now? 3,400 liters. Now, to now convert it to money, to cash, you now multiply 3,400 liters with the cost of diesel in your location. In Nigeria, here, the cost of diesel is 1,150. So when you want, you are spending 39.1 million. Now, when you now go with solar, right? Go with solar, instead of running it at 75%, you're now running generator for 60, that's 25%, which is 60. Still the same period, which is 200 hours. That will give you 200 times 60. That is 12,000 hours. All right. So in a month, the liters that we are consuming is 12,000 liters against the 34,000 liters when we've not introduced PV. So when you now convert that 12,000 that you buy this in Nigeria, 13.8 the savings you are saving more, which is how to do analysis. All right, so this is where we are going to see when we start the main training. We've only got to the capacity, which is 650. We've not started designing. All right. Now to now start designing, you now need to know the module that you need to use, the inverter that you need to use. You now begin to size your BOS and the rest. So by the time we start the training by April or May, then we are going to be looking at that. All right, so this is where we are going to end for today. At the end of the class, you're going to receive the slides. So if you have any question, the floor is open now. Abdul Razak, your hand is up. Adeyinka, your hand is up as well. So you guys should ask your question.
Yes, thank you for having me once again. While we started the generator stuff, I was having a serious network challenge to the extent that I couldn't get everything. Okay. But then, thank God for the recording. I know maybe I might catch up during the recording. But the question I want to ask here is, since we did for the generator, and I noticed that from your explanation or from the beginning of our training, you never made mention of anything like the battery backup. Does it mean that the battery backup will not be able to carry the capacity of all these big industries? Or does it mean that the cost is higher than having the generator? I think that's my own question, because I notice most banks now, what they use battery instead of the generator stuff that we had here. Thank you.
All right, thank you. So the reason why you didn't hear me mention battery is because we are treating PV diesel. All right. So by next week, when we move to AC coupled system, we are going to see how battery can be integrated into the system. Of course, battery can be integrated into the system. Back then, battery use, the reason back then, as let's say like 3 years ago, 5 years ago, when the cost of battery is much, you will hardly see where battery is being integrated, because by the time you bring in battery, the CapEx will be way too much, and the client will not be able to have tariff. But now that we have economic of scale, the cost of battery is dropping. So if you go to most industry now, you see them integrating battery with their system. So obviously you can use PV diesel. So to next week, a couple system, I will talk about it.
Okay, sir. Thank you very much, sir.
You're welcome. Adeyinka, your hand is up.
Yes, thank you, sir. The first question will be, the slide you because generator or the grid knows that the PV is want to deliver 70 kilowatts, because the total load is 100. Now the PV is supplying 70. How
Okay.
will the grid know that the PV is supplying 70 and be able to regulate himself to suit that thing, and he will be able to supply 30? That is one.
Okay.
The second one, the controller. Are we going to install each controller for each of the generating plants? You know, we have for grid, we have for PV, we have for diesel. Each of them, are they going to have different generating different controller?
All right.
Thank you.
All right, you're welcome. All right, so now what the PV will give out is determined on the controller. You don't need to bother yourself. The controller knows what is going to supply. So that 70-30 is the controller that is doing the ratio. I've explained everything in the slide that the controller, if you check, I explained everything that the controller, let me go back so that you see it. Let me go back so that you see it. Now you can see, maintaining maximum output of solar system while protecting the DD. This is achieved by reducing the output. It is the controller that will do everything. It is not you. Once the configuration has been done, then the controller will handle everything. All right? Do you get that? Then what is your second question again? Let me try remember.
The second question is the controller. Are we going to have different controller for
No.
No.
It's just one controller. One controller can handle multiple generators and grid. It's just one controller.
Okay. Okay. Thank you.
You're welcome. All right, Boyejo, your hand is up.
Okay, so my question is for the minimum loading on the generator now. Say for a company that runs either 9 to 5 or 24 hours, what's the longest time that you can run generators on minimum loading? Like, is it safe to run on minimum loading for a very long time, like 24 hours or 12 hours?
All right. So there is no specified time. It's better not to start what you cannot. It's better not to start what you cannot prevent later on. So don't just start it. There is no particular time that you should run. There is no particular hours. Your generator, OEM will not tell you that run it for a light load for 200 hours. Then after then, don't run it on light. There is no hours. Don't just design. Just consider a minimum loading. All right. I won't be able to tell you that it is after 2 days. No. Question is, don't start it. Don't start what you cannot finish. All right. You get that?
Yeah, that's no problem.
All right. So Abdulrazak, I think you are the last person that the hand is up. Abdulrazak, you can ask your question now. All right, so if there is no question, this is where we'll be stopping for today.
Yeah, sorry, sir. Sorry, sir.
Oh, yeah, ask your question.
Yes, sir. I don't know, maybe if you can be accessed after the training, sir.
Definitely. You will get it in your drive.
Okay, sir. Okay, sir. Thank you.
Drive, so you get it.
Okay, thank you, sir.
All right, Ines, your hand is up.
I'd like if all solar plants have charge controllers, or it's for smaller
All right,
systems.
so all solar plants have charge controller. All right. We have PWA. Not like shutter. Do you understand? So it is when you are doing residential that you can decide to get an external charge controller. All right, but for a large farm, your charge controller is the MPPT and it is inside the inverter. Do you get that?
Yes, thank you so much.
All right, you're welcome. So any other question? All right, so today is Lord spend five. By next week, I think just like I mentioned when we started that this is just a free, you understand? By the time we start the design proper, the certificate is not compulsory. I'm just reiterating for those that didn't join earlier on. The certificate is not compulsory, all right? But if you want to enjoy subsidized cost of training in the one that we have in October, in November, sorry, in May, because in May we'll be talking about the design proper, all right? Just like I've stopped here now, I will continue from the PV diesel where we know the number of modules, inverters, we'll be using it. And we'll talk about MU scope, all right? Then the next training, which will be by August, we'll talk about PVCs and PVKs. Then by, I think September, we'll talk about the financial model, all right? And I mentioned to you that if you are persistent and you are serious, at the end of this year, you should be C&I good. That once they work, you should be able to attempt it, all right? So the certificate is not compulsory, but by during the week, I think Bashir will paste something like that so that you guys understand. Which training is it by April? Having a paid training by the month of April, all right? It's going to be paid, not free. But if you have the certificate, you will be paying a way below the amount that others that don't have the certificate to pay. Those that don't have certificates can be paying as more than 70, 80. But if you have certificates, you'll be paying below 40. You're paying below 30 as well. So I don't know what the discounts will be, but just letting you know that it will be at a discounted price. All right? So as my tech universe. No, we are stopping this. Please, why training time having much more? This one we are doing this to be uploaded. So just exercise patience, all right? Why your question won't space? Nobody will have in Kenya will they come? Okay, so we want to carry everyone up. Can you Ibrahim, your hand is up, ask your question.
Okay. Thank you very much for the presentation. To raise a concern, I think from all the discussion, maybe I don't know if I missed any part of it, you didn't discuss about the sizing of transformer.
Oh, you need the sizing of transformer?
Yes, sizing of transformer.
When you talk of, transformer is, we are transformer is just a subsidy, is part of and it is not all C&I that makes use of transformer. But when it comes to that system, you don't, because obviously everybody is what transformer. Everybody should know how to size transformer. So that's the reason why I didn't mention that. But when it comes to when we get to the design proper, you understand, where we need to arrange everything, because in the training I'll be having sometimes in April or what's it called, May, we are going to have like a case study, and we are going to run the case study from start to finish, including the SLD as well. You understand? So we are going to see if it needs generator, if it needs transformer, you'll be able to tell, oh, it needs transformer. You understand? So that's the reason why I didn't mention the transformer.
Okay, thank you very much. Yes, thank you.
You're welcome. Now, is it possible to visit a site where we can see often it is because after by next month there will be a site visit for those in Lagos, Abuja, and even if you are not there, you know, those that have the appropriate to use fuse instead of, now it's appropriate to use fuse if you want to size, and the type of fuse I use is high ruptured, high, they call it high capture. See that you just use. Let me see. When is the next training? It's still online. The next training was like I'm in Lagos. Okay. Can the drive link be shared on WhatsApp group? It's already there in the WhatsApp group. Just go to link when you log into the WhatsApp group. Type of fuse that you use. High for it's well spent. Let's call it a wonderful weekend. So everything in hours. That is what Bashir mentioned. So once you receive it, watch the recordings, go through the slide, and if you have any question, any objection, any contribution, the WhatsApp group is there. Just drop it. If you want to reach me personally, you can also do that. So good day, everyone, and enjoy the rest of your week.